Hi everyone, and so welcome back for the second video that I was talking about. And this video is actually about the updates on the mass spectrum stuff with my MATLAB programs. So what I've programmed is actually now a way for you to do ranging in MATLAB. That I think is the way that I always thought it should work. Okay, so I hope you agree, and I'll just quickly show you how it works. So the first step, of course, is again to read in a .pos file. And I've just noticed I've still got the figure from before open. And then read in a range file. And same thing as before, read in range files, stupid tabs. And now, and that's already something I showed before, we can plot the mass spectrum with the ranges attached to it. So that's new, okay? And that is actually fairly helpful. And it's got some stats, some stats that are also part of the whole thing, right? So you can see here that we've got, it says what the bin width is, how many atoms are in there, what the background at Fort Dalton is. The reason why the background at Fort Dalton is actually because usually there isn't much happening at Fort Dalton because hydrogen is usually 1, 2, or 3, nothing at 4, and then usually carbon's the next one at 6. Obviously, that's not always true. Sometimes that's actually not true at all. And then we've got all of the different things here. And the y-axis is actually now a normalized y-axis, which I think should actually be used more often in Atom Probe. I've not always been someone that always did it, but it's actually very helpful because it makes different mass spectrum more comparable. So what it actually shows is actually how many percent of the entire atom count is within within 1 Dalton, right? So if your bin was 1 Dalton wide, how many percent of the mass spectrum would it be? So of course, if you've got the main nickel peak in this nickel-based superalloy, it would be 10 to the 3%. Obviously, it's not 1 Dalton wide, and that's why, you know, this is on a per Dalton basis. Anyway, you can actually redraw that whole thing if you change the ranges, and that goes very quickly as well. And so you can see here we've got titanium, and this already looks like it's probably not titanium. Here we've got chromium, and then so on and so forth. And I'll just show you a couple of things of what you can do with the new ranging tools. So I'll just delete all of the ranges from 22 to 28. So I can just simply do that by going into the range variable and look at, okay, this is 22, this is 28. So I'll probably want to delete everything from 22 to 28. Just go delete rows, and now we've got 49 ranges instead of, I think we had 55 before, whatever. And I can actually replot the mass spectrum by using the spec command, and it actually goes very quickly. Yep. And now I might be interested in rearranging them. And the new ranging tool is actually called the, what did I call it? selectIon user interface. That name might change. And you can see there is a couple of commands that I've attached to that. So if I call the selectIon graphical user interface, I pass the range variable by its name, okay? So as a string. It's kind of like passing a pointer in C, and I had to do that because of some of the limitations that I haven't found a workaround for with MATLAB's graphical user interfaces. Then which mass spectrum plot I want to do the ranging in, so this is why we've called that spec. Then which elements I think are in there, and you can, I can for example go titanium, chromium, molybdenum, blah, whatever the hell. But I can also write all just means all elements. Then the next one is the complex formers. So which elements form complex ions? And standard stands for hydrogen, carbon, nitrogen, oxygen. Okay, but you can explicitly, for example, go molybdenum forms, whatever. Standard is just that the elements that always form complex ions. The next part of the command is actually which charge states I expect, and in this case I'll tell it, okay, charge states 1, 2, and 3. If you have tungsten, maybe you have 4 as well. If you have voltage measurements, maybe you never have 1 plus, so you can get rid of 1 plus. But this is the charge states you expect. This is the maximum complexity of ions you expect. So complexity of 2 means I maximally get molecular ions with 2 ions in them, with 2 atoms in them. But you can have it up to however many you want. Just be aware that that means that the computation in order to make the list of the possible ions just explodes the larger the combinations is. So if you do a combination of all ions with, you could also put all ions here, right? So all ions with all ions up to a complexity of 3. That's just a massive amount of ions. So please be aware that this might be this. Essentially, I'm not limiting you with anything, but yeah, just use common sense. The next thing is the abundance threshold. So above which abundance we think we will want to arrange the ions. So you can make that 0, which means it takes all isotopic combinations of a given ion. But if the relative abundance is usually less than 0.5% or whatever, I just drop them. Right? But you can make it 0 if you want. And then what color scheme you want to use. So if you put in a range file and for whatever you are arranging currently, there is already a color defined, then it will keep using that color. But if there's no color defined, it's good for you to have a color scheme. Okay, and you can see here I've created something called a random color scheme. Oops, wrong one. Random color scheme is just a list, a cell list of names of types, so elements, but you could also use noise or unknown 1 or whatever and give it a color. Okay, and it will use that if there is if there's nothing defined in the ranges. If there's nothing defined in the ranges and there's nothing defined in the color scheme, what it will do is actually ask you for a color. So it will just pop up with the color selection tool. The next thing, so this is actually the end of the command. So this is all good. So this would be it. But then I want my mass spectrum to be updated. So I've just put the update mass spectrum command that I've just used up here. You might recognize it from here into the same line. So it automatically does it. And after the updating, it will actually switch off the panning, and I want the panning to be on it again. So yeah, it's not that important. It's just so that all of that is in one line, but doesn't need to be. Okay, it's just this again, and then the exo. Maybe what for demo purposes, I'll just get rid of it so it's easier to see. Anyway, so if I call that, it will pop up with me. Try and arrange it. Now I'll take the big titanium, and what happens next is it will pop up with a graphical user interface which shows me the possible ions around there, and it defaults to whatever ion is closest to the peak, and it shows you the information what ion it is, how close it is to the peak it found within the range that you've defined. Gray is the range, by the way, and it will show you what the relative abundance is. So the closest would be germanium 72. In this sample there is no germanium. I know there's no germanium. So I can just go down, titanium. And what you can see also is it will update where the other peaks are. And we can see, okay, yeah, that fits pretty well. Apart from this bugger here, so this is probably not titanium. And And yeah, and this is enough for it to know what range it is, and I can click on OK, and it will have added that range to my ranging plot. And you can see here there's now the titanium again. In this case, there is no volume defined. I haven't implemented that yet, whereas all of the ones that come from IVAS have the reconstruction volumes associated with them. And now, if I want to update the spectrum plot, then I can update the spectrum plot, and there we go, it's here. But there's also a neat little trick in there that you can use that makes ranging of multi-isotope elements or ions really easy. So I can, for example, pick that bit here, okay? And it says, okay, zinc, blah, whatever, is probably not that. Titanium 46, yeah. And what I can do is click range same. What range same means is it accepts that this is titanium 46. By the way, you can manually always change the ion name. Okay, this will always override the information from up here. So it just defaults to titanium, but I could call it my titanium. Just anything that can be a MATLAB variable. If it can't be a MATLAB variable later, when you decompose your POS file based on these ranges, it will throw an error because it won't be able to assign something that starts with a number or something that contains special characters. Apart from an underscore, underscores are fine. So if I go range same, what it will do is actually it will take me through the other isotopes and let me range them as well, or other isotopic combinations if it's a complex ion. If there is a range that already exists, just press enter and it will skip it. And we'll also want to skip that. And just like that, we have updated our mass spectrum. Okay. And of course here, this is supposed to be chromium, so I can go select ion graphical user interface and click on it, and where's that? This is chromium 50. Do the same thing, go range same. And there we go, update the mass spectrum, and there we go, chromium 50. Chromium with all its isotopes. Anyway, so this is actually really handy for ranging, makes things very quick and easy. So the bugs that are still in there, so there's actually 2 bugs that are still in there, but they're not going to bother many of you people. So the first bug is when you do the range same command, then occasionally it goes to a isotope that doesn't exist at first, with the first range, and I have no idea where that comes from. I really need to go look deep into that. And the other thing is not a bug really, it's behavior that's not been implemented yet, and that behavior is that you can have, so if you have complex ions, you can have different isotopic combinations that have the same mass to charge, or that just weigh the same. Just imagine, I don't know if those isotopes really exist, but just imagine you've got iron 56 and iron 57 and carbon 12 and carbon 13. So if you combine carbon 13 with iron 56 and carbon 12 with iron 57, it just weighs the same. And right now I haven't implemented any measures for you to be able to pick which one it is, or essentially it will just find 2 ranges and crash. Okay, so that's not implemented yet. Yeah, so in this case you just can't use the range same command, but everything else works fine. Okay, so this is actually hopefully going to make everyone's life with ranging a whole lot easier, because it gives you an educated guess of what the ranges are and makes the range assignment a whole lot faster. I hope I'm going to get to fixing the bugs in the not too distant future, but anyway, it works for now, and so yeah, have fun.